So we are back to talking about the normal distribution. So remember, in statistics, normal distribution just refers to a bell-shaped curve. It's not normal as in versus abnormal. It's not like other distributions are weird. This is just one that we study in detail. All right, so we are learning how to find areas underneath our bell-shaped curves. The next question that we're going to do is we're going to use the Z-score table to work backwards. If you know the percent or proportion under the curve, you can find the corresponding Z-score. So I will remind you every single time that I think making a sketch can be very helpful to some of you. So I'm going to make a sketch of a bell-shaped curve for each of these. All right. And example A wants the 80th percentile. Now, what does it mean to be at the 80th percentile? It means there's 80% below. Well, if we're dealing with a standard normal distribution, the center is 0. And if I were to split it in half, I would have 50% and 50%. So if I want the 80th percentile, I must be well over the halfway mark. So I'm going to mark this as my 80th percentile, and I'm going to draw my perpendicular. And I'm going to shade what to me looks like to be about 80%. So this region in here is 0.8000. Now, why am I going to 4 decimal places? Because I'm going to be looking at my Z-score table and I'm using it in reverse. I need to know what Z-score is this. Well, the fact that I'm on the right side of the center means I know it's got to be a positive Z-score. So look at the positive side of your Z-score table. But what you're going to do is you're going to read it backwards. And by that, what I mean is you have to find 0.8000 in here. Now, you may not find it exactly, so you have to find the closest you can. So let's see. I'm looking right in here. I'm looking at these guys right there. So this is 79.95%, and this is 80.23%. Which one of those is closer to 80%? Is 0.7995 or 0.8023 closer? All right, he is definitely closer. So the answer is going to end with a 4, and it's going to be 0.84. This Z-score is 0.84. So on the standard scale, a Z-score of 0.84 is your 80th percentile. Now, example B says Q1. Okay, the quartiles are percentiles. They're measures of location. Q1 means what percentile? Okay, that's your 25th percentile. So 25th percentile means I need to be on the left side of the halfway mark so that when I draw my perpendicular and I shade it in, I should only be looking at 0.2500. And since I'm on the left side of 0, I need a negative Z-score. So go to the negative side of your chart. So you got to find in here the closest you can to 0.2500. Okay, so I'm looking at right in here, right there. Do I like 25.14% or do I like 24.83%? All right, they're pretty close, but this one is 0.17% too small, and this is 0.14% too big. This one's a little bit better. So the answer is going to end with a 7, and it's actually going to be negative 0.67. Now, you don't need to memorize that because you could look it up anytime you need to, but what you need to understand is those numbers will never change. Okay, the 25th percentile, Q1, is always negative 0.67. Do you know what Q3 would be? We'll get to it. It's later on the page. We'll get there. Okay, so that's the Z-score table. Now, the Z-score table, again, you will have this. It's in your formula pack, so you'll get it on every test day from me. You'll get it on AP exam day. And I've actually had some people in the past tell me, I like the Z-score table. Other people like, I never used it again, Mrs. Ferrer. You showed us how to use our calculator, and I never touched that thing again. Because you can do all the same stuff on your calculator. Now, you might say, then if we can do it on the calculator, why do we ever use the table? Well, I like to show the table because I do like people to see where it came from. I mean, that table, somebody created that table by doing calculus over and over and over again so they could come up with, when I was in school, calculators didn't do this. We had to use the table. So I think you should know how it works, but now I am going to teach you how to use your calculators. All right, you're going to be looking for a feature called normal CDF. Now be careful, there's also a normal PDF, but you don't want that one, okay? That's something that can be used for graphing the normal distribution. You're going to be looking for normal CDF, and the C stands for cumulative, okay? So we are accumulating data. You think about it, as we move from left to right, we are accumulating data. So look for the C. All right, for each problem, you will need to state a lower and an upper bound and the mean and the standard deviation. Now, for us right now, because of what we're doing, we are on a standard normal distribution. Our mean will be 0, and our standard deviation will be 1, okay? As long as you're working with standard scores, that's all you need to know. All right, so let me clear out my memory for my 84. And let me clear out my memory here. Okay, so both of my calculators are wiped clean. All right, so as always, I am going to remind you to draw a sketch. So I'm going to do that. I like to draw pictures. So every single one, I'm going to draw a picture. Every single one. Here's a normal distribution. Here's a normal distribution, also known as Madison's hair. All right, so if we're dealing with a standard normal distribution, we're centered at 0. And the first guy says we want Z is less than 0.86. So positive Z-score means I need to be on the right side. So this is my Z-score of 0.86. I draw my perpendicular, and I want to shade to the left. All right, so I'm going to emphasize, you could use the table will work, but we're going to use our calculators on this one. All right, so I'm starting with my 84 just because I grabbed it first. All right, you need to be where it says distributions. Can you see that above your variable button? So second distribution. And option number 2 is your normal CDF. Again, not PDF, you want C. So choose option 2. All right, lower bound. If you remember anything, hey, scientific notation, -1 times 10 to the 99th power. That is a very large negative number. As far as we're concerned, we're going to call that negative infinity. And that's what we want because this thing is shaded off to the left forever. So that's our lower bound. Our upper bound stops at the Z-score of 0.86. And you'll notice the calculators are pre-programmed. Look what they default to. Even they know mu is 0, sigma is 1. So you can just arrow through all that. And you'll notice you get a lot of decimal points. Okay? Go to 4 decimal places so it matches our table. So 0.8051. So this really should say the probability of this happening is 0.8051. Now, if you did look at the table, 0.86. There it is, right there. 0.8051. You get the same answer, but you don't have to read the table. You just get it out of your calculator. Okay? So the next one, I'll do the next one on the Inspire. So once again, I actually, this notation is bad. It should say the probability that Z is greater than this. So now I have a negative Z-score. So it's going to be down here somewhere. negative 1.43. I draw my perpendicular, and I want to shade greater than. Remember yesterday how we talked about we sometimes have to subtract from 1 and stuff like that? You won't have to worry about that on the calculators. It'll do it for you because you can enter your upper and lower bounds. So I am just going to go to my calculator. So I'm just going to go to my scratch pad. All right, so everything on an Inspire is somewhere in your menu. You want to go to probability because we actually are calculating probabilities here. Distributions, option 5. And there it is, your normal CDF, option 2. All right, now this one is going to be in reverse. Right now it comes and says the lower bound is negative 9 times 10 to the 999th power. Okay, that's more negative infinity than the other one was. But that's not my left bound this time. My left bound is negative 1.43. Your upper bound, this shading is actually going off towards infinity. Now, you don't have to type in a scientific notation. I literally just type in something like that. Okay, the bottom line is, think about the standard curve. 0, add 1, add 2, add 3. You understand if you, what I have here, 1 million, you realize how far down the scale I am? If we're scaling by ones, that's close enough to infinity. All right, again, mu 0, sigma 1, that's what we want. That answer is 0.9236. And doesn't it look like that answer should be nearly 100%? So that's why I like the pictures. And if it gives you a range, well, then you're not going to use an infinity number. You're going to say, I want to go from negative 1.2, and I want to go up to 2.63. And I'll just go back and do this. You can throw that away. I'll go back to my 84 on this one. So distributions, normal CDF. All right, now my lower bound is at negative 1.12. My upper bound is 2.63. I'm going to stop right here. Older 84s, are yours looking like mine, or are you getting something different? Are you guys okay? All right. 0.864, and I would round that to a 4. 0.8644. So again, this really should say the probability. 0.8644. So you just found that proportion. In other words, in that distribution, you could say that 86.44% of the data is in that interval. It's not so bad, is it? Like the calculator or the table better? Most people like the calculator better. And they're more likely to have their calculator with them than their tables. You know, always fold that table up, keep it in your wallet. Never know when you might need it. All right. So yesterday we did the table, what I call reading the table forward, and then we just read the table backwards. Now we use the calculator going forward, and now we're going to learn how to use the calculator going backwards. You will now be using something called inverse norm. So you're doing the normal distribution as an inverse. Use inverse norm when you know the area or the probability and you're looking for the z-score. Use normal CDF when you know the z-score and you're looking for the area. This, as crazy as it might sound to some of you, this is where people get confused. They forget which one to use. On this one, you will need to know the desired area or proportion. So it means you might have a percentage, you might have that 4 decimal number, and you still need to know the mean and the standard deviation. But again, for right now, we're still going to be using the mu of 0 and the sigma of 1. And they'll probably be in the calculator for you. All right, and as always, I recommend making a sketch. All right, where is your 17th percentile? Where is it? Where's your 17th percentile? Okay, way to the left of 0, because we're saying there's only 17% under it. So your 17th percentile is way back here. Now what you have to remember is 17th percentile means 17% below, or in other words, this little area right here is worth 0.1700. That's what it means. I have the percentage. I have the little area. So it's when you know that and your Z is the question mark. Now we use inverse norm. All right, I'll go back to my Inspire. All right, inverse norm, menu, probability, distributions. Oh, look, there it is, inverse normal. Okay, Inspire, well, actually anyone. You cannot come ask me during a test, do I use normal CDF or inverse norm? And don't ask me where it is on your calculator. You need to know by testing, okay? So inverse norm is option 3 here. And it even tells you what it needs. Area, 0.17. There's your mu of 0, your sigma of 1. That is now a Z-score. And Z-scores get rounded to 2 decimal places. So I would call that negative 0.95. All right, Q3. If Q1 is your 25th percentile, Q3 is your 75th percentile. So 75th percentile, so think of 75% below, so think of 0.7500. All right, so we're centered at 0. If I went 75% below, I'm way up here somewhere. So Z is my question mark. And this whole area is 75%. 0.7500. Does anyone know this answer yet, by the way? Without typing in your calculator? Okay, yeah, I hope you can write. It's the symmetry again. If this one is negative 0.67 with 25 and 75, this is going to be positive 0.67 with 25% here and 75% over here. But we'll go through it on the 84 just to double check. All right, so you are going to go to second variable. So you're going to distributions. There it is. You guys have your inverse norm, area 0.75. Now, what you guys also have here, you have an option. So our tail was colored into the left, so that's what we want. And to be honest, I try to draw it like that almost every time, so I'm not changing that. But you could switch and do a center region or another right tail region. 0.67, just as we predicted. So positive 0.67. You don't have to put the positive there, but I put that just to emphasize the difference between example 4B. All right, we will finish up example 7, and then for tomorrow, make sure this data is in your calculator, please. That long data set, make sure that's in for tomorrow. Can we do that? All right. You can complete exercises about proportions of observations in any normal distribution by standardizing first and then doing the work on the calculator. So a pediatrician obtains the heights of her 200 3-year-old female patients. So to be honest, you may not need that. That's your M size. The heights are approximately normally distributed. This is important because if they don't tell you this, then you shouldn't be drawing a normal distribution and doing all this stuff. All right, the mean is 38.72 and the standard deviation is 3.17. So this would be this pediatrician's group. We want to find the proportion of 3-year-old females who have heights less than 35. All right, so here we go, notation. The probability or proportion that a height is less than 35. All right, watch my notation because I'm going to want this back from you on test day. The first thing you're going to do is you're going to convert this to a Z-score. So the H is going to be turned into a Z. The less than is going to stay the same, but now you actually have to do the conversion. And how I've organized myself for years is I do it right underneath here. You know the formula for the Z-score that I told you to memorize? Do you know it? Okay, so Z equals X. X is whatever value it is you are trying to work with. We're trying to work with a 35. Minus the mean was given as 38.72. Divided by the standard deviation is 3.17. Okay, so the first thing we do is we go to our calculator, and I'll just even use this guy. I'm going to put my numerator in parentheses. 35 minus 38.72 divided by 3.17. So the Z-score is negative 1.17. And that goes right here now. So basically what you did was you took, and you can go back and think about the class heights. Okay, we set up that scale of our class heights that we have measured in inches, just like this person did. It's now been converted so that it's now on this scale. It's now centered at 0 and using these simple numbers for standard deviations. So this 35-inch female is at a Z-score of negative 1.17, so she'd be like right about here. Okay, all we did was convert onto the standard scale. And now you whip out your calculator. Okay, you draw a picture if you want. Doesn't have to be super accurate, but you're like, okay, I know it's now centered at 0. Negative 1.17 is like maybe right about here, and I want less than. I like the picture because it allows me to see. It's like, okay, my left bound is infinity, and my right bound is the Z-score. I'll go back to my inspired. Menu, probability, distributions. I know the Z-score, so I go to normal CDF. Lower bound, negative gazillion. Yep, that's what I want. Upper bound is negative 1.17. 0, 1, that's what I want. 0.1210. So you can read that answer as a proportion, a percentage, a probability. You could say that in general, out of these 200 patients, about 12% of them are below 35 inches. That's what that really means. It also means that out of those 200 patients, if the doctor randomly selected one, there's a 12% chance that that one person is going to be smaller than 35 inches. Okay? This is the notation I want to see. Set up the problem as it's written, do the conversion, and then look up the answer. The proportion of 3-year-old females who are between 30 and 40. Proportion whose heights are between 30 and 40. Now on this one, you're going to have to do 2 conversions. Because when I put this into a Z, I have to convert each of these. So the first one is going to be 30 minus 38.72 divided by 3.17. And the second one is going to be 40 minus 38.72 divided by 3.17. So what do I have for those Z-scores just to save us some time? Do I have this written down? I do. I have this comes out to be negative 2.75 because that one is below average. This one is above average, so that came out to be 0.40. All right, I'll go back to my 84. Distributions, normal CDF. The lower bound is the negative 2.75. The upper bound is the 0.4. And I get an answer of 0.6524. Now, I didn't draw a picture there, but I certainly could have. I could have said, well, I know one of these measures was below average, one of them was above average, and therefore I know that I'm going in between those two. The height of a 3-year-old female at the 20th percentile. Okay, this one is different now, because this one I don't have the Z-score. This one, I have the area. 20th percentile means back here, below average, and it means I have 20%, 0.2000. I don't know the Z-score this time. This is now going to be an inverse. All right, back to my Inspire. I just keep flipping back and forth. Let's see, probability, distributions, inverse. Area is 0.2000. So the Z-score is negative 0.84. Z equals negative 0.84. All right, so now when I go to use my formula, it's the Z-score that I know. And what I don't know is the height. The mean is still 38.72. The standard deviation is still 3.17. But now I'm solving for a different part of that equation. Now, you can write down that negative 0.84. But you know what? You don't have to retype it in the calculator. It's right there. I'm just going to multiply that answer by 3.17. And then I'm going to add the 38.72. So this person, someone at the 20th percentile, has a height of about 36.05 inches. So you're going to get lots of practice on that Z-score formula and on the homework. So at this point, you can continue the homework into part 2. And it says right here, you are not required to use the table for any exercise. You can use your calculator every single time if you want, or vice versa, okay? So you should be able to get the homework done up to number 61. And then we have one more part of this to finish up tomorrow. Put that data in your calculator, please, to save us some time.